Hello guys and welcome back. So I'm gonna go over these folders. I've gathered multiple different things and I'm gonna go over each one of them. They're not in any orders by any way, and each one of them I'm gonna talk about something or explain an idea for you guys, and hopefully it's gonna make things easier and give you guys more clarification. Now, before we dive into this, as you can see, we're setting up the road for something completely different and custom with destruction. Or like any setups you would do in Houdini, you would have a problem, you come up with a solution, you R&D a few ideas, you figure out the ideas that you like, you pursue the R&D or the ideas that you preferred the most and the most efficient ideas, and you create a workflow out of that. That workflow is not going to magically you're not gonna magically become a master of that workflow that you just made. Yes, you're not gonna master it in few hours. It will take a lot of iteration, and this is something typical with any Houdini setups. You have a problem, you create the solution. It takes time to master that solution, to understand all the controls. This applies to smoke solver, for example. I create my own smoke solvers. It takes me weeks to figure out exactly what are the best settings to use, what is the main driver for to get the look I want. And this is something, there's no shortcut for this. There's nothing I can give you guys to help with this. You have to practice, you have to get do the R&Ds, you have to do the tests, you have to get comfortable with the whole workflow. You have to understand how the knobs affect the look that you want, what you need to change to get the look that you want, and stuff like that. There's absolutely no shortcut in that. There's no more shortcut that I can provide you to save you time or reduce this mastering process. You have to go through the steps to get there. And for me, after I got the full setup of the various layers, it took me exactly 2 weeks, working more than 8 hours a day and doing multiple iterations on the sim, on the main sim, on the high res sim, testing renders with motion blur, seeing how that result looks and what I need to change to get the final result I want. It was not just right up a given after I finished the setup. There's a lot of time that I had to put in to get the result I want, and that time there's nothing more I can teach. You have to do a sim, look at it and say, okay, I don't like the speed, I'm gonna fix the speed. You do one more sim, now I fix the speed, I don't like the way the Kong is moving, I'm gonna do something about that. So you change that thing, and then you do the uprise. You don't like the uprise, it's crumbling too much or eating away too much, so you go back, reduce that. Now it's reduced too much, so you go back and fix that. And these stuff, there's nothing really amazing about them. We just have to do the iterations to get there. Okay, so this is the animation folder, the animation file, and you guys will have access to this. Cool. And this is a video preview of the building, and I'll let it play. I think this is an older version that had these paved, that metallic structure, and the geometry were a bit more high res. I think so. Let's see, maybe when I have a wireframe. Yeah, it's hard to tell, but I had two versions. One that was very high res, about 60 million, and then I did poly reduce on various parts. Yeah, this is the high res one. You can see the ground here. It's like it's very high res, and this is without fracturing. It's 15 million. So if we add the fracturing in, it's going to be around 60 million for this. So this is the building preview. And all this was again modeled in Houdini using various techniques. Okay, this is the reference for the city. Actually, this is a kit, or you can buy this from photobash.org. You can buy the whole Dubrovnik if you want to find more reference and stuff like that. Okay, so let's see what this is. This is an initial test with the high-res geometry before I did any poly reduce or anything like that. It's not the final geometry by any means. What I use this test for is just to see how the pieces are reacting, and I can easily spot if when there is issues. You can see this block here. Sorry, let's do this guy. So you can see these guys here, they are not getting separated, and that's because the name attribute did not get set up properly. Okay, I need to see every single piece fall correctly. Also note that there is no fracturing or anything at this point. These are just the unique pieces falling down. You can see there is no fracturing at all. Okay, and it's still the pieces are still grouped together, and I included the tower, and then yeah, this is different angle, and I believe, yeah, and this is no, it doesn't include, yeah, it does not. It includes better, it has better separation now, but there is no fracturing. These are just the pieces separated by themselves. There is no fracturing at all. And again, I do this just to test and see that everything falls down. There's nothing exploding, nothing crazy. The machine doesn't crash, Houdini doesn't crash, Bullet is happy, all that stuff. Let's take a look. This is the particle dust using airfield, and so this is a technique that we're going to create. You can see the effect here, how this is rolling. Yep, and let's take a look. So that's one effect, and this is another. The main difference between the two is the emission. The emission source is different. One is being emitted from the edges, and the other is from a different area. I can't remember. That's the dust. Okay, I'm gonna leave this for the end. It has multiple different it has different random tests, and this is the full edit. So Urban did the cinematography that placed the camera. I gave him a low res version of the building and a proxy version for all the buildings, so it's easier to scrub. He did the camera, I did the render, and then he did the edit and music for all of this. And you guys can check the YouTube version. Okay, so that's there. Okay, this one is to show how much we can, how crazy we can go in terms of details. Again, the sim time is still very reasonable, and this is a capture that I did a while back, but I didn't use this because the amount of details was way too high, so I didn't want to, I think it's too much. Yeah, I didn't see a reason to keep this, so I reduced the amount of details. Okay, so there's that. Some wedges, some preview for the animation, and this is I wish I showed this in the beginning, but this is an example of the main sim. Okay, you see here there's no secondary fracturing, there's no separation, there's nothing. This is the main sim that I did. It's actually very fast. It has all the bending behavior, it has all the pieces, all the primary pieces, no windows, yeah, no no wood, no glass, no tiles, just the core pieces that are important. This guy too, you can see here it's exploding, and Kong is hidden obviously. And so this we then ran through an upres process. This is still the same preview. Let's see. And this is the upres process. Now see that we kept all the primary behavior of the sim, and we've added a lot of details here. See, everything is, there's tons of details added. I think this is not the final version. It is the final version, but it doesn't include all the elements. No tiles, no wood, no interior details for that metal and square thing. So this is the main idea. So on the left is the main sim, and on the right is the high-res sim. Okay, these are some still images from the workshop. I'm not sure if they're all included on our website, but they're not all from the final version. I had multiple iterations. You can see here, sorry, you can see, for example, in this one the amount of details is much higher and the pieces are crumbling a lot more. Anything that got to this level is basically crumbled or got reduced to rubbles. And so that's something I fixed in the next version. I didn't want everything to, go into dust or get reduced to rubbles. I wanted to keep the core of the pieces. And so I went back and did some more R&D. The dust, the particle-based smoke, or the particle-based dust, was not present on all the renders. And in some, I had to tweak the particle size based on the screen, based on the camera position. I didn't bother. I did just a couple of frames, a couple of shots, and that's it. So these are just still frames, and these are the final composite. But actually, it's very, very similar. We're going to talk about that when we get there. There's not a huge difference. These are actually renders, just renders, A over B. And these are previews, some stills. Okay, these are some studies which we will talk about for substepping and how important it is to properly understand the difference between bullet substeps, dot substeps, and stuff like that. And this constraint system has bending, it has clustering, which we're going to talk about. It has a mixture of pin and glue constraint, and there is the impact data here being streamed out, so we can use that to do any kind of debris if we wanted to. This is a preview of the layering technique that I was developing at an early stage. It doesn't have all the features. This is just a partial implementation, and the full implementation is with a full building. But you can see actually this one, this is a great example. Now again, don't worry too much if this sounds a bit complicated, but this, apart from the upres, there's also the swapping technique. So I added geometry that didn't even exist in the primary sim. Okay, so I went from 100 or 200 pieces to 2 million pieces, and not everything in the primary sim was present. So like all the layer, the entire layer, this wood, metal, and all these small base squares were not present in the initial sim. Okay, And so this is a very complex concept, but once we get a grasp of, we can really push things to the extreme. You can see how the primary sim is driving all this, not just the front layer, but is driving even things that didn't belong to it. And you can see how we can get some very high-res details with very little effort. Now the primary sim has constraints, the secondary sim does not. We can obviously set up a constraint for the secondary sim, and we'll talk about that once we get closer to setting this up, and once we have more understanding of what we want to do. Okay, so there's that. This is a quick test of the upres workflow. There's some Arnold motion blur issues towards the end, but in the beginning everything is working as expected. Okay, this is another early test of the upres technique. You can see all the crumbling. Once the original sim is very low res, it's basically, you know, these blocks, and it takes like 3 minutes to do the main sim, and the secondary sim is very fast as well. Trying to do trying to get all these details in the same sim is not going to be a pleasant experience, especially if you get a note that says, oh, can you please turn these pieces off, or can you do something to, you know, reduce the number of pieces, or any change will require a drastic change to your sim, which will result in a big visual difference, and that's something you don't want to go with. Okay, let's see, this is another test. Yeah, this is another test for an upres using, I believe, a sphere, just to push to see how this low res technique would work with an upres that also includes a swap or an addition of geometry. Let's call this a swap geometry. So you would use a proxy version and then you swap it. With this, we actually used this geometry, but we only broke it into 100 pieces. And also it's very important to test with motion blur, to test normals and things like that. So this is the same test with I can't remember. Yeah, it's this guy, but with proper gamma. So I'll delete this. And then these are multiple tests for various different constraint settings. You can see how the bending works and how the clustering works. You get blocky structure along with the mixed. You get various different RBD sizes. You know, big, small, mid, tiny, and stuff like that. So this is a great thing to achieve in one setup, and that's one of the things that comes with my custom workflow. So this is another thing for the bending and holding the structure. This is a metal like thing, so it's basically built as if there is a metal inside of it that holds these blocks together. And here I'm testing the solver. This is not great. I'm testing the solver settings with a constraint and a bullet constraint to see how that affects the sim. This is not, I'm not changing any settings for the constraint or anything like that. And we're also going to talk about wedging, and we're going to create these UIs to add this information. And I have a script to add the sim time, and this is something that you guys can implement as well to test various settings. If you're curious about, I'll point out the things that I think are important, and then once we have the system set up, we can test various different widgets and print that to the screen if we wanted to. So we'll set that as well, and these are different tests. And here I'm testing how to work with a geometry that is animated in SOPs and a geometry that is animated and active in DOPs. This is a test using Houdini 17 soft constraint, which I'm not sure what to use it for, but yeah, we're going to look into that. This is one test that I did, an early test, where everything quickly crumbles into basically the smallest level, and this could be used to create some really cool effects, but it's not working in this case. So you can see here the process has not been, you know, one click and you get there. There's definitely a lot of iteration that I went through to either improve the setup or iterate over things. This is an implementation of an FOM like using Tidra highlights geometry, but using a bullet. We're going to talk about this. You can see the bending, you can see the stretching and tearing there. We're gonna this is something that we can use to create metal like bending and tearing. Metal deformation is easy if you want just bending, but it gets really complex if you want tearing and hold that up. So right now it feels like a flesh tearing apart, but I'm gonna do some more work on this to basically make it hold itself, so when it stretches it stays at its maximum stretched information or stretched state. And so this is something that you guys can play with as well. And this is initial test for the upres technique. So the primary layer is 1, 2, 3, 4, 5, 6, and then I run it through the upres process. You can see here all the pieces. Once it separates there, it should have happened sooner, but once it separates it starts activating. Now it doesn't activate just like that, it activates from the outside and it starts eating itself. You'll see it crumbling as it continues to play through. You will see it crumbling. See, this piece is they all continue to activate as they basically as the time goes on. And this is the fracturing here is done using the Boolean, I believe. Yeah, it's done using Boolean for the secondary layer, which can be forgiving if you have low-res geometry. This is a preview of the connection information that I use to trigger the activation of the secondary pieces, and then I use a solver to propagate that information to the rest of the geometry. And this is another test of the erosion effect. You can see it here. Once it starts activating, it erodes the whole piece into bubbles, and so we need to I had to implement a system that can keep it from doing that, so we can maintain a core for that block. This is the same test, a different angle. This is a preview of the windows. An earlier test of the glass that was not the constraint was not strong enough, but you can see everything is crumbling except these guys that were attached to the wood. Okay, I think that's pretty much it. Thank you guys for watching, and see you in the next video. Bye bye.